Yes, hello dear student. Once again, welcome for our online lessons, Vision Plus channel. In the previous subtopics, I was taking people through uh, hydrocarbons, and we said hydrocarbons are split into three. We have the alkanes, alkynes, and at the same time, we look at alkanes, their general formula. Then also we look at some formulas. So we said we have the what we call the molecular formula. We also have what we call the structural formula. We look at what we call the isomers and also isomerisms, and we differentiate between the two. Then now we are going to look at isomers, how they are named, and the name of isomers is going to base on IUPAC. IUPAC is simply stands for International Union for Pure and Applied Chemistry. So we are following this body that you shall be in position to name the organic compounds or the hydrocarbons that we are going to look at. But there are the steps that you are supposed to follow, the steps that at the end of the day you will follow and you end up getting the right answers. So step number one is that we have to identify the what? The longest continuous carbon chain. This is the very vital. You have to identify that long chains. Then after that, you will be in position to determine what we call the parent alkane. The parent alkane is that one, that longest continuous carbon chain. Then step number two, we shall be in position to identify the substituent groups. Now, when we talk about the substituent groups, we shall get them ahead. We shall have something called the nitro group. We shall have also halogens. We shall have uh, many other things, etc., etc. Then now, from there, we shall be in position to say that this one here, they are here, when you look at them, they are here like just branch. They are branch, like you have the continuous long chains, then you have these other branches, and we call them the substituent groups. Then number three, we shall be in position to number the what? The longest chain. So after identifying that longest chains, you'll be in position to look at the branches. Then you need to you need to number the longest chains. We're starting from where? We start from the end. Now that from the end is that which is near to what? It is near to the branch group, such that we shall be in position to get the lowest possible number. Now we shall look how to get this lowest possible number from examples, but we are simply saying that if the branch is on carbon 2 or is on carbon 2, carbon 1, we shall pick that one off carbon 1. Why? Because it gives us the lowest possible number. Then step number 4, we shall be in position to determine the positions and the types of what? Types of branches. So the type of branches here could be, we shall have methyl, if I say CH3, like this we are seeing, this is what we call the methyl group. Then if it is ethyl, we say, the moment I see ether, that means we have 2 carbon atoms. Then also here when we say propyl, we have 3 carbon atoms. Until we continue. Now, according to the what? To the number of carbon atom attached. So we shall see from the position, we shall be in position to get the number of carbon atoms where this one is attached, and we give it the lowest possible number. Then now we're going to use the prefix di. Di mean 2. This is 2. Of course, tri, 3. Tetra is what? Is 4. But when you look at this thing critical, most of the thing you'll get them ahead when you continue with the organic chemistry. But mostly here we shall stop maybe in di and tri. So we are going to use these prefixes to show the number of what? Of branch groups attached to the parent alkane. These are the basic steps you're supposed to follow. After following this thing, we shall now be in position to name these examples given. So how can we name this? Now let's say step number 1, identify the longest continuous carbon chain. So when we look from here, the longest continuous carbon chain is from here up to here. Why? Because we have 1, 2, 3, 4 carbon atoms. Then now, when you look at this branch, it's just a branch. We have 1, 2. So this becomes the shortest chain, and this is the longest chain. Of course, there are many other chains. Okay? You will see a branch somewhere. So what you're going to consider, you're going to consider as the what? The longest continuous carbon chain. Now, then from there, this one becomes the parent alkane. Why? Because this other one is just attached, it's just a branch. So that will take us to step number 2. Identify the subsequent groups. These are molecules that are not part of the chain and appear as branch groups. Okay, let's check the branch group. The branch group is here. We have seen it already. Then now we shall be in position to number. This is very vital. Number the longest chain starting from the end of the chain, and that's this near. So I can start numbering from here and say this carbon 1, this is carbon 2, this is carbon 3, this is carbon 4. I can also number from this side, carbon 1, carbon 2, carbon 3, carbon 4. So number the longest chain starting from the end of the chain that is nearest to the branch. So this is the one nearest to the branch. But now we want to see how we get the lowest possible number from here. So we start from the ends, then also near to the what? To the branch group to get what we call the lowest what? The lowest possible number. How can I get the lowest possible number? If this is the branch, now on branch we have 2 and 3. So the lowest possible number from here is going to be 2. Why? Because we cannot start numbering from this side. The moment we start numbering from this side, we shall not get the lowest possible number. So after getting the lowest possible number, what will you do? You determine the position and the types of branches. So now the position here is 2. We have seen position is on carbon what? Carbon 2. That is the positions. Then you determine like the type of branches. What branch do we have here? We have the methyls. From here, we have the what? The methyls. Now you will be in position to arrange in this form. You have seen that the branch is on carbon 2, so I'll start putting 2. Then after putting that one, I'll now look at the branch. The branch is what? Is the methyl. So I put just hyphen here like this. Then I say methyl, of course, methyl. Then from there, we shall be in position to come back to the parent what? Alkane, and we say 1, 2, 3, 4. If it is having 4 carbon atoms, and this one we see is a single bond, we shall say this one is called butane. So the whole thing will become 2-methyl butane. So that's the simple way you can name that compound. 2-methyl butane. 2 is this one, the position of the carbon atom where the what? The branching has started from. And we are considering, we want to get the lowest what? Lowest possible number. So that's why we cannot start numbering from this side, because it will not give us the what? The lowest possible number. It is here where we can get the lowest possible number, and it is 2. So we shall say 2, and the branch is what? The types of branching is what we call methyl. So we shall have 2-methyl butane. Why are we saying butane? Because we have 1, 2, 3, 4. 4 number of carbon atom, but then the reason why we are saying it is butane, because there is a single what? A single bond between these carbon atom. In other words, you are saying saturated hydrocarbons. Now let's come to Roman number 2. It is just very simple. We are following the procedure. So first of all, we start by what? Checking the longest parent alkanes. So we shall say 1, 2, 3, 4. Now let's count this 1, 2, 3. So this becomes the longest what? The longest chain. From here now I can start numbering. I can say 1, 2, 3, 4. I'm numbering the what? This longest continuous carbon chain. But now for me to get that lowest possible number, I have to make sure that the branching should be, okay, we are going to start from the end where the branching is near. But also someone can number and say we shall have this become carbon 1, this is carbon 2, this is carbon 3, this is carbon 4. Now 3 and 4, the lowest possible number for us here is 2. That's why we are increased to we start numbering from where the branch has just started from. So for that reason, we shall now be in position to say that the branch, let's look at the type of branchings. We have methyls and we have methyls, but they are what? They are two. So that takes us to where we say we shall use prefix like di, we shall use tri, we shall use tetra until we get what we are looking for. So here we shall be in position to say that this one is on carbon what? Carbon 2. So I will start by saying 2. So that means I've started for one branch, methyls. Then I put comma. Again, this branch is on carbon what? On carbon 2. Why? We are picking this lowest what? Possible number. Don't pick 3 because it cannot give you the lowest possible number. So after putting these two, you'll be in position also to put another 2. Why? Because this branching also is on carbon 2, the positions. So then you put hyphens. The two branches, we use the what? Di. So we shall be in position to say di. But the types of branching is what we call the what? The methyl. This one and this is methyl. So we're meaning this branch. So we shall have dimethyl. Let's come back to the longest chain again and we say 1, 2, 3, 4. So we have 4 number of carbon atoms and we have 4. We can say simply this one become but. Now for us to add ANE is also very something very crucial here. We need to look at it very well. How come for us to add ANE? Why? Let's look at the what? Let's classify this thing whether it is saturated or unsaturated. And we say the unsaturated hydrocarbons, they have either triple or double, triple, yes, or double bonds. But for saturated, they have only single bonds in the what? The carbon atoms. So this one become automatical butane. Now, how can you pronounce this? You'll be in position to say that the name of this organic compound is called 2,2-dimethylbutane. This is the very correct spelling. This butane, don't put the space, it's just like this, 2,2-dimethylbutane. Now let's go to Roman number 3. Very crucial. And if you have been following enough, by this time you'll be in position even to name this number 3. But let's go through it briefly. Here we are saying you first identify the what? The longest chains possible. How can I identify the longest chains? I'll be in position to say that I start from here 1, 2, 3. Now if I count these chains, I'll be in position to say 1, 2. So that means this one becomes the longest what? The longest continuous chain. So I'll start numbering. I'll say this is carbon 1, carbon 2, carbon 3. I can also number from the other side. I can say it. I have this carbon 1, this carbon 2, this is carbon 3. Now, if that is the point, then we shall be in position to say that these carbon atoms where you're seeing the branching is carbon, the position is 2 in the longest chain. Now, for us to get the lowest possible number, we say we start what? Numbering from where the what? The end part where branching is. But this one now will give us 2 to be the lowest possible number, and also these 2 also will become the what? The lowest possible number. Don't confuse this one with this, because when we look at this second example, we are saying that this one here we are having how many carbon atoms in the longest chain? We are having only 4. But now for this one, we have 3. That's why the lowest possible number is coming 2, but also when you number from the other side, it's also going to be 2. Now, how can I name this one? I will start with the 2, which is the position of carbon atoms where branching is starting. Then I put the hyphen. This is very sensitive. After putting that, I will look at the what? At the branches. So this branch, the type of this branch is what we call methyl. So if that is the case, then we shall be in position to say that, how about this longest chain? How can I determine it now? I'll be in position to say 1, 2, 3. And we'll say from previous subtopics that we had, when you say when you have 3 carbon atoms, we shall be in position to say pro But now we shall be in position to say pro, but we shall be in position also to see that this one, when you look at it critically, it is saturated hydrocarbons. Why? Because when you look at this, when you look at the bonds, here is single bond. So when you also open this one up, structurally you see that it is what? It is single bond. So we shall be in position to say this one is called 2-methyl propane, and that is the name. So naming organic compound is very simple. You only be in position to go through these procedures or the steps that are supposed to be followed. Then after that, you'll be in position to start numbering and naming. Thank you for your time. We meet in the next lesson.